Let's solve third problem of step 6 term examination paper Mathematics 2 2022. Okay, third problem up to this part is related to Olympiad problems. Also, if you wanted the solution how to work on rest of the problem, you can send message to my WhatsApp number. But up to this part, because it is work on, for example, SN, we have so much similar problem in SMT, Stanford, Math Tournament, AMC, BMO, how to work, how to find something inside itself. In Olympiad, we have lots of problems like this. Okay, let's start the Fibonacci sequence, and because the Fibonacci sequence is so much famous, the Fibonacci numbers are defined by f of 0, f0 equal to 0, f1 equal to 1, and for n greater than equal to 0, fn plus 2 equal to fn plus 1 plus fn. It has lots of properties. You can find closed form, lots of things. Okay, so let's work on first part. It says prove that fr is less than or equal to the r minus r n fn for all n greater than equal 1 and all r greater than equal 1. For this part, you can use induction. You can also prove it by telescoping product or telescoping rule. Again, telescoping rule is so much famous in many Olympiad problems. BMO, British Mathematical Olympiad, AMC. So let's solve it with telescoping rule. Okay, and for solving this, one of the most useful idea at first, we work on small examples. For example, suppose r equal to n, because it says r is at least n. Left side will be f of n, right side will be 2 to the n minus n fn, which will be 2 to the 0 times fn, which is fn, and we will see it's correct. Now, if you want to prove for rn plus 1, you can say f of n plus 1 is less than or equal to replace r with n plus 1. 2 to the n plus 1 minus n is 1. 2 to the 1 fn. And it is equivalent because we know fn plus 1 by using this is fn plus fn minus 1 is less than or equal to fn because each term is sum of two previous terms. So here instead of fn plus 1, you can write fn plus fn minus 1. Now, if we subtract fn from both sides, it is equivalent. That's why fn minus 1. Let's write question mark because we want to prove it. Equivalent to prove it is less than or equal fn, and we will see it's correct. Because Fibonacci sequence is increasing function 0, 1, 1. After that 2, 3. So fn minus 1 is always less than or equal fn. And so on. 13. And so on. Now, for example, for rn plus 2. You say fn plus 2 is less than or equal 4 times fn. So, one way use induction, another way, I say, okay, for this part, I say fn plus 2 by, let me call this one star. By star, we know each term is less than or equal to 2 times f of previous term. So, fn plus 1 is less than or equal to fn plus 1. And it is equivalent at fn plus 1 over fn plus 2, sorry. Fn plus 2 over fn plus 1, because fn plus 1 is not 0, we can divide the less than or equal to 2. And because n is at least 1, so both of them, only f of 0 is 0. The other terms are positive. And similarly, you can say f of n plus 1 over fn is less than or equal to. And if we multiply, then we call it telescoping rule. Fn plus 1 here, denominator, numerator will be cancelled. So fn plus 2 over fn is less than or equal 4, which is exactly this that we wanted to prove. Okay, now if you use same thing, here we want to, but look, you don't need to write this part, this is for yourself. For fr less than or equal to the r minus n fn. So let's prove this part. Now we've understood the idea. We say we want to reach r is greater than equal f. So fr we know over fr minus 1 is less than or equal to by star. Star was what here? Always it is less than or equal each term, less than or equal twice previous term. fr minus 1 over fr minus 2 is less than or equal to fr minus 2 over fr minus 3 less than or equal to up to last term fn plus 1 over fn less than or equal to. Now, if you multiply all of them, it will be fr minus 1 times fr minus 1 over fr minus 2 times fr minus 2 over fr minus 3 times fn plus 1 over fn less than or equal to the power of what? Look, from r minus 1 to n, you can say last term minus first term plus 1. It will be what? N minus r minus 1 plus 1. Oh, sorry, here because r is greater than equal n, let's consider something. If r equal to n, we've proved. So here we can say r is greater than equal n minus greater than equal n plus 1. So the number of fractions, last one minus first one. We know that r is at least n. For r equal to n, we proved. Now we conclude r equal to n. Proved r is at least, for example, n plus 1. So here you say last term minus first term plus 1. So it will be r minus n. 1 and negative 1 will be cancelled, so it will be 2 to the r minus n times nothing. Okay, because we have these 2's, we have r minus n 2's. Now, this part will be cancelled with this part with this part, and so on. You cancel up to this part. So we will prove that fr over fn is less than or equal to the r minus n, and this part fr is less than or equal to the r minus n times fn. And we proved this part. Also, you could easily prove by induction. I just wanted to show you how you can prove with telescoping product. Okay, let's solve second part. It says let Sn equal to this. Show that last part, this part is the most important part. It's so much similar to many Olympiad problems. This part, telescoping product, so much useful. But this part, when you have something, sum of something to infinity, you should find something inside itself. We have lots of problems like this, and I will write some homework for you. Before that, let's solve part 2. Okay, let's solve this one. And when something like this, you have sigma, it's hard, try to expand it. For example, here we know Sn equal to f1 over 10 to the 1 plus f2 over 10 squared plus f3 over 10 cubed plus 2 fn over 10 to the n. Okay, now here let's focus on left hand side. Okay, we have 3 terms. Let's focus first on the first term. Sigma r equal to 1 to n fr plus 1 to 10 r minus 1. So if you replace r with 1, it will be f2 over 10 to the power of 0. Plus if you replace r with 2, f3 over 10 to the 1. Plus f4 over 10 squared. Up to fn plus 1 over 10 to the n minus 1. Okay. Now here, if you compare it with f1 with Sn, I want to write it in terms of S. I will say first thing that you should have f2 here, we have 10 squared. Here, f2 is 10 to the 0. So here I should factor from 100, then it will be f2 over 10 squared plus f3, it will be okay, 10 cubed. Up to fn will be 10 to the n, and fn plus 1 over 10 to the n plus. Now for writing in terms of Sn, because we have Sn here, 89 Sn, you need f1 over 10 and you should subtract this. So it will be 100, I write minus f1 over 10 plus f1 over 10, then it will be 0, it has no effect. That's the reason I can write equal to. Plus, so here, f2 over 10 squared plus f3 over 10 cubed up to fn over 10 to the n and plus fn plus 1 over 10 to the n plus 1. Now here, this part is what? By definition of Sn, it is exactly Sn. So 100 times negative f1 over 10 will be negative 10 f1 plus 100 Sn plus 100 times 10 to the n plus 1, it will be fn plus 1 over 10n minus 1. And as you can see, negative 10 fn you have here, and fn plus 1 over 10 to the n minus 1 we have here. So let's n minus 1. Let's focus on this term. Okay, so let's write this part as A, this sigma as B, this sigma as C. So we found, let's erase this part, we found A is what? Now let's focus on B. And all of them are considering left hand side. B is what? B is sigma r equal to 1 to n fr over 10 to the r minus 1. So if you replace r with 1, it will be f1 over 10 to the 0, and plus f2 over 10 to the 1 plus f3 over 10 squared plus 2 fn over 10 to the n minus 1. It is so much similar to Sn. The only thing we should have, multiply by 10, divide by 10. So we multiply by 10, then we divide by 10 inside bracket. It will be f2 over 10 squared plus f3 over 10 cubed plus to fn over 10 to the n. So here it will be Sn, okay? So it will be 10 Sn. Last part, C. For calculating C, it will be what? Sigma r equal to 1 to n fr minus 1 over 10 to the r minus 1. So it will be, if I replace with 1, r with 1, to f0 10 to the 0, f1 over 10 to the 1 plus f2 over 10 squared plus 2f. If you replace the last one, r with n, fn minus 1 over 10 to the n minus 1. Okay. Now here, f0 is 0, we can ignore that. Now here, I add fn over 10 to the n to write it as ns, to write it in terms of sn minus fn 10n. Then it has no effect because it is 0. So this part will be sn minus fn over 10 to the n. Okay, now let's compare. Here, we have a minus b minus c. For a, 100s and minus 10s and 90s and minus s and minus 89s. And so this part will be okay. By this part, this part, this part. Now, here we have negative 10 f1, it's okay. Because we have a minus b, for minus b we don't have anything, but for a, fn plus 1 over 10 to the n minus 1 we have this. Because we have minus c, in minus c we have what? We have negative fn over 10 to the n. And here we have, because we have minus c, minus minus will be plus. And here it has been written minus f0. And minus f0 will be what here we had. f0 is 0, so we can ignore that. Okay, so we proved part 2. Now in part 3, the last part that I want to solve, as I said in the beginning of the video, for rest of that, because it is not so much similar to Olympiad problems. If you wanted to know the solution or how to approach these types of problem, or also other problems of step 2, step 3, if you want to learn how to approach, feel free to send, or also for Olympiad, feel free to send message to my WhatsApp number in the description comments. Also for TMUA and CSAT, that are for computer science, for applying Cambridge. If you wanted to learn those ideas, also you can send message to my WhatsApp number. Okay, let's focus on part 3, this part. Okay, now I want to show you how you should use, let me tell you, how you should use recursive sequence and how you can find something inside itself. It is f1 over 10 to the 1 plus f2 over 10 squared plus f3 over 10 cubed plus f4 over 10 to the 4 and so on. Okay. We call this one S, and we want to find S is what? We want to prove S is 10 over 89. So the problem says f1 is 1, f0 is 0, and other terms are, for example, f2 is 1. There are fn is fn minus 1 plus fn minus 2 for n at least 2. Okay. Or you can write fn plus 2 equal fn plus 1 for n at least 0. They are equivalent. f1 is 1 over 10. But from f2, let's write also f2. f2 is 1 also. So it will be 1 over 100. For f3, we can write it as f1 plus f2 over 10 cubed. The next one, it will be f2 plus f3 over 10 to the 4. If you write next one, it will be f3 plus f4 over 10 to the 5, and so on. So it will be 1 over 10 plus 1 over 100 plus. Now I consider only first term of each fraction. f1 over 10 cubed plus f2 over 10 to the 4 plus f3. You can also use previous part, but I want to show you a way that it is not needed to use any parts. And now we focus on second part of each fraction. It will be f2 over 10 cubed plus f3 over 10 to the 4 plus f4 over 10 to the 5, and so on. Okay, now here, this part, as you can see, s, it is exactly s but over 100. Okay, because it is f1, it is over 10, it is over 10 cubed, 10 squared, 10 to the 2. And this part, so let's write it is 1 over 10 plus 1 over 100 plus s over 100. But this part we don't have f1. So at first we should do something, because here we have f1 over 10, f2 over 10 squared, but here we have f2 over 10 cubed. So we factor from 1 over 10, and it will be f2 over 10 squared. In 2 steps we reach from this to s. f2 over 10 squared, f3 over 10 cubed, plus f4 over 10 to the 4. Now, the only difference that is left between here and s, we don't have f1 over 10. So we add f1 over 10 and we subtract 1 over 10 plus 1 over 100. Let's write it as 110 plus 1, 11, plus s over 100 plus 1 over 10. Now here we say negative f1 over 10 plus f1 over 10. Then it will be 0. It has no effect if we add f2 over 10 squared, f3 over 10 cubed, and so on. So here, from this part to this part, it will be s. Now, we know we have s here equal to this part. So if we add s equal to 11 over 100 plus s over 100 plus 1 over 10, and we know f1 is 1, so it will be minus 1 over 10 plus s. Okay? Now, let's multiply both sides by 100. So it will be 100s equal to 11 plus s, and 10 times negative 10 will be negative 100. If you multiply by 100, it will be negative 1 plus 1 over 10 times s, which will be s over 10 times 100 will be 10s. Now it will be equal to 11s plus 10. Why s plus 10s? 11 minus 1, 10. Now if we subtract, or if we take 11s to left hand side, 100s minus 11s will be 89s equal to 10. Now if we divide both sides by 89, s equal to 10 over 89. So it is our answer, and as you can see, we should prove that it is equal to 10 over 89, and we proved this. Okay, pay attention to this idea. We've done something. For example, we've used a recursive sequence, and we found s in terms of s inside itself. This idea is so much useful when you want to find something. Let me write some homework for you. For Stanford, for example, math tournament, Harvard, MIT math tournament, some problems like this. For example, 2 over 2 plus 2 over 2 plus 2 over and so on. Try to solve part A. It is what? You should find again something inside itself. Part B, try to find square root of 2 times square root of 2 times square root of 2 and so on. Part C, a little harder. Square root of 2 times square root of 3 times square root of 2 times square root of 3 and so on. Part D, square root of 2 plus square root of 2 plus square root of 2 and so on. Part E, square root of 2 plus square root of 3 plus square root of 2 plus square root of 3. And for example, part F, you can solve, find 1 plus 1 over 2 plus 1 over 3 and so on. Part G, you say R is absolute value of R less than 1, 1 plus R squared plus R cubed and so on is what? And next part, if FGH, absolute value of R less than 1, try to find R plus 2R squared plus 3R cubed. It has two solutions. 4R to the 4, try to also find this. Okay, look, all these problems have a background idea, and the idea is what? Exactly the idea I've told you here. Find it inside itself. In all these problems, you should find it inside itself. Look, so background ideas are so much useful. If you learn background ideas, there are not so many ideas, so you can learn them. And then if you improve your problem solving with only few background ideas, you can cover all problems. And also you can solve hard problems that there are few students that can solve. Okay, if you wanted to learn more ideas in calculus, in STEP, TMUA, CSAT, combinatorics, geometry, algebra, number theory, and also other topics in math, also in competitive programming, informatics, if you want to learn important ideas, feel free to send message to my WhatsApp number in the description and comments. Okay, please don't forget to subscribe, turn on the bell, and like the video. Be safe. Take care. Bye.